Yeah, they're indeed called ternary operators, and I don't know why I'm going into, like, that's just semantics. Maybe that doesn't matter so much. Okay, so back to this. So, yeah, so I didn't want to do this since I understand Python enough. This is like something to show that, hey, I understand Python. I can do ternary operators in Python in a clutch manner. Okay, here we have if not winner. I'm going to print it as a draw. So it's like if it's still none. Otherwise, you're going to print out the winner with this F string. So, okay, cool. So this is good so far. Analyzing the code is going okay. So I'm going to go up here and go to CheckWinner. So what does CheckWinner do? So CheckWinner is this function here. This is probably, if I were to come back to this program, I'd probably maybe work on improving CheckWinner. But so what I did here is I created a visited board where it's basically set to false, because what I'm going to be doing is kind of like a DFS, a depth first search method, and because of that and how I have it set up, I really want to know if I've already visited something, because then it'll have an infinite recursion. Otherwise, or I don't do recursion. Sorry, I actually do an iterative method, but it would have an infinite while loop or infinite iterations. So here, I don't think this is that clever, but here I just basically I set the winner equals, I check vertically, because like, how can you win in Tic Tac Toe? There's only a couple ways you can win. You can win either vertically, horizontally, diagonally, but there's two diagonals. There's a diagonal, a main diagonal, and then there's a I call it a secondary diagonal. So there's total going to be 4 ways you can win. So you can see I have 4 things that I checked to see if they won. Check vertically, check horizontally, check the main diagonal, check the secondary diagonal. And basically, if at any point we do get a winner, it won't run these. Like, there's no reason to run these. If for some reason when you check vertically, you realize there's a winner, and you set that winner to true here, and then because you know whose turn it is, well, not that, sorry, it's this one, right? So this one just says winner equal to the turn. So if winner is true, it'll say winner equal to the turn. Alright, so let's look at what these check vertically do, because these are where I kind of struggled. So to check vertically, I get what the current piece is at the current position. Like, maybe it's an X. And I just add it to my queue. Like, here's my current position, add it to my queue. And then I create this while loop that will keep going until the queue is empty. And so I pop out the queue, that's my first thing, and get the 2 coordinates. And I check if the board is not equal to that piece. If the piece at that location that I'm looking is not equal to the original piece, like if it was an X and an X like right here, like if it went up and installed the O, right, it would return false and you'd be done. But otherwise what you do is you set visit equal to true, and then this is like the, you go, if you can go above, like if you can go above and move upwards, you append the upwards. If you can move downwards, you append the downwards. And you only do this if it's not visited. So if it's visited, you don't search or add it to the queue, because you've already kind of looked at that and you already noticed that that piece is equal, because you didn't return false. So if it makes it through this while loop, it returns true. And then also I have check horizontally, which is basically the same thing. It's just instead of ranging through the rows, I move through the columns. Same code. I could probably make this into something, I could probably combine these, to be honest, but okay. Then we have check main diagonal. The main diagonal goes from 0, 0 to 2, 2, so it goes from here to here. So like I won the main diagonal. Oh, I already got rid of it. I think I won the main diagonal here. Did I? Yeah, right here. So here I won by getting the main diagonal. So this code checked and it returned winner for this. So for the main diagonal, you basically just want to like, you want to go down and to the right, or you want to go to the left and up. So those are your 2 options. So either this one is going down and to the right, and this one's going up and to the left. Just the basic things you want to do for that. Then I also have check secondary diagonal, which goes from the other corner, from this one to this one. And for this, you want to move in a different direction, so I coded the direction you want to move in. Yeah, because instead of moving, one way, you want to move this other way. The other thing is, I'm not going to go into that too much. I also forgot to mention that basically you're only going to check the main diagonal if I is equal to j, because that's the only way you can be on the main diagonal. The only way you can be on the secondary diagonal is for this condition, for I to be less than j minus 1. And you can think about, and this is true because if you're right here, I is equal to 0 because it's the first row, but j is equal to 2. So take 2 minus 1, and you have is 0 less than 1. That is true. And it turns out that to be on the second diagonal, this condition is always true. So I figured out, like, if you're here, here, or here, so that you have the main diagonal, which is when I and j are equal to each other. Then you have these stuff that's not on the either diagonal. There's 4 of these, and they basically kind of surround the center tile. Oh, that's what they're called. They're called tiles, I think. Okay, I'm going to start calling them tiles. So it's like they surround the center tile. And yeah, so I mean it's pretty basic what it does here. So I don't know why I said that, but this is getting really bad. But yeah, so I mean basically the difference is always 1. It always turns out the difference is always 1, while the difference between this I and the j and the difference between I and the j for this one, for these two secondary diagonal, is that they are basically greater or equal to by 2. I also just realized something else. You also do want to check this is equal to j, because you could, that was a mistake I made, because you could be here, like you could have placed a piece here, but you still need to check the secondary diagonal. Ooh, that was a mistake I made. Okay, so I just found a mistake. Okay, so now there's one thing I want to do. So I'm going to try to do this without editing this video, without doing anything. I'm going to add a feature to this print board. Okay, so we print out the board, but I'm thinking when you print out the board, let's print out this thing. Okay. Whoops. I'm gonna have to name these different. So I guess I'll name these map 1, map 2, and map 3. And so what I'll do is basically, I'm trying to remember how this will work. Does this work? If you print like this, they'll be side by side, I think. Okay, let's check this out. Yeah, that's what I want. So now anytime you make a move, you'll have that thing to look at. Alright, cool. That's a feature I wanted to add. So yeah, I'm done. So it was an interesting, pretty good project. But cool, yeah, we did it. I did it, I guess. But yeah, making Tic Tac Toe is a very good project to practice Python. It's only pretty short too. This is a little over 100 lines of code.